Welcome to another episode of the Scaping podcast. My name is Daniel and this is a podcast for the geospatial community. My guest on the show today is Ed Neerhout. Ed is a project manager at Meta, a fantastic person, and today on the podcast we are going to be talking about Mapillary. So I've previously published an episode about Mapillary, and I'll link to that in the show notes, and also include some other links in the show notes today to other relevant episodes that you might find interesting. I would be remiss if I didn't mention that this episode was recorded some months ago, but due to some technical issues and some major life upheavals, it is only being published now. That being said, it's a fantastic listen, and I really hope you enjoy it.
Hey Ed, welcome to the podcast. This is absolutely great to have you here. We've talked a bunch, but we've never recorded the conversations, and this is what we're doing today. Today, I really want to have an update on Mapillary. I know you have a ton of history with this product, with this service, and that's what I'm keen to chat about. You're a product manager at Meta. Why don't we start there? Why don't you just give us a brief overview of who you are, what you do at Meta, and then your relationship to Mapillary?
Sure, Daniel. So hi, thanks for having me on the podcast. So yeah, I'm currently a product manager at Meta. This is a new role for me. I've, I guess, had a history of working with a community around Mapillary. And then as Mapillary became a part of Meta 4 years ago, I started working on a lot of our strategy around OpenStreetMap and community building, given that Meta uses a lot of open map data. And so that was kind of my foray into product management, and then started thinking about tooling. And so right now I'm working on a few different things as product manager at Meta, but maps tooling is one of them. Maybe we talk about some of the other stuff, but Mapillary has been something that I've been working in for around 10 years now.
Could you just tell me how you got involved? What was the story there?
Sure. So I was actually studying in Sweden. I moved to Sweden in 2014, and I was studying something completely unrelated. I was really interested in foreign tech companies in China. And as I was doing my master's, I needed a job, and I was looking at interesting companies in Sweden. I know there were a lot of like incredible startups in southern Sweden and then across the water in Copenhagen. And I found Mapillary and just emailed them pretty much almost to the day 10 years ago.
Wow.
Just said like, hey, I love what you guys are doing. Like this idea of building a database of the world using street level imagery and using phones to map the world. And yeah, just emailed them, asked if I could find a role there. And luckily they got back to me soon after. And yeah, that was the very beginning of a really incredible journey with Mapillary.
Yeah, that's really cool. So just to clarify, you had no sort of prior interest in mapping, background in geospatial. You just saw this, the startup and thought, wow, that is awesome.
Yeah, I had no background in mapping other than just loving it since I was a kid, like looking at atlases and maps. And so that was the seed. And so when I was looking at interesting startups in Sweden and saw one that was related to maps, it like immediately jumped to the top of my list. And already like it was very early days with Mapillary there. I think they had 6 people working on the team, but there was already like an incredible community swell around it. Images were coming in from around the world. And that was a really intriguing thing that I think I resonated with, but I know a lot of other future employees and also people contributing resonated with.
And I can see that now with the numbers. I think maybe we should dive into those a little bit later on. Maybe we've jumped in a little bit deep. There will be some people listening to this that don't know what Mapillary is. Could you give us an overview? What was it when you started and what is it now?
Sure. Yeah. So what's funny is in preparation for this, went back to your 2019 episode with Jan Erik and listened to that. And I thought, this might be a bit out of date now. And I listened to it and it's like, there was hardly anything there that I thought wasn't relevant today. And even if you go back to 2013 when Mapillary started, I think there's still a lot of relevance in the original idea. And so the idea of Mapillary is that obviously map data is hard and collecting map data is hard. But in 2013, all of a sudden we had these smartphones in our pockets that had GPS, the cameras were getting a lot better, and there was computer vision technology, there was improvements obviously in cloud services where you could scale a platform like this really quickly. And so the idea of Mapillary is to build a platform which people could contribute to easily to with cameras and their smartphones, to build a street level imagery platform and then use computer vision to derive map data from that imagery. And so we can talk a bit more about that and how that's useful. But it was this convergence of cameras and smartphones and GPS and the ability to scale a platform around that to get map data in all different places around the world.
And what happens to that map data? What is it used for, and who gets access to it?
So the map data is used for all sorts of different things. It's pretty much the majority of people contributing to Mapillary are doing so because they want to understand the world around them in some way. They're building a map or they're updating a map. And that can be anything from asset management that cities are doing, keeping track of where their traffic signs are located. We've had a lot of use cases around the humanitarian sector and identifying buildings that might be susceptible to flooding, or working out which parts of a city have good cycling infrastructure and which parts of the city have bad cycling infrastructure. So there's a variety of different use cases. And in the past, Mapillary used to make the data available for OpenStreetMap under the ODBL license, and then we would charge for commercial use. And one of the good things is when we joined Meta in 2020, we're able to open up a lot of the data and make it available for anyone who's interested in using it. And so it's much easier now for a company or a researcher or anyone with an interest to use the imagery. And so we're seeing a kind of a resurgence of all these exciting use cases, which we can talk about.
Yeah, I'd really like to talk about that later on. But at the moment, so we understand that Mapillary is a platform where people can upload imagery to it. It says in my notes, any device. But mostly we've talked about cell phones at the moment. What other devices can we use to upload imagery to Mapillary?
One of the big changes that I think has probably occurred since 2019, when you spoke to Jan Erik last, is just how many more 360 cameras there are. And so if you go back to when I joined Mapillary in 2015, I remember we would get these weird looking 360 cameras in the office, and some of them were Kickstarter campaigns and they were clunky. The software was fairly bad. The hardware was of varying quality. They were expensive. But these were kind of the pioneers in 360 cameras. And then since that time, I think in large part due to companies like GoPro and Insta360, there have been a resurgence of good 360 cameras that can be used for mapping. And I think their primary use case was actually people taking reels and nice ski videos, nice surfing videos. But we've been able to benefit from that, particularly the ones with GPS. So I mentioned smartphones earlier, but particularly over the last 5 years, we've seen much more of the imagery on our platform coming from cameras like the GoPro Max, which is just a very easy to use action camera. And then you have all the way through to like the professional grade cameras, the Trimble cameras, the Mosaic cameras. There are a bunch of names that may or may not mean something to the people listening, but these are the kind of cameras that collect very high resolution imagery. They're quite expensive, but they're used by cities that are maybe doing asset management at a very high frequency and want to be able to zoom in and look at an address, or they need that crisp imagery. So we have the full range.
So my guess is with the higher resolution cameras, you can extract more details from those images and therefore derive more data from them?
Yeah, precisely. You can imagine if someone is, so we have our own computer vision algorithms running on the imagery, but then there's also people that are using Mapillary imagery and writing their own models to derive extra things. And so there's people that have been doing optical character recognition, where they can read text in an image and then discern what kind of place am I looking at? What does the restaurant name say? And if you have a grainy image, like a lower quality image there, it's hard to read text. So that's one example where you really do want a higher resolution image.
And what does the upload process look like? How do I get these images into Mapillary?
So for your smartphone, you're going out into the world using our app. Maybe you're mounting it to your windshield, or maybe you're walking down the sidewalk and capturing sidewalk imagery. But that is fairly easy. You've captured imagery. It captures imagery automatically as you go based on the distance that you've traveled. You go home, and then as soon as you're connected to Wi-Fi, it starts uploading. For the action cameras like a GoPro Max, which is a popular 360 cam, you can just take your SD card out, put it in your computer, drag the files to a desktop uploading software that we have called the Mapillary Uploader. And yeah, you just drag and drop it. And one of the improvements we've had over the last few years is we've added support for a bunch of different camera types, 360 cameras, to make it that drag and drop process easier. So we handle the GoPro Max, we handle Insta360, and there's a file format called CAM, which is kind of a common 360 file format that we also support. So it's much easier than it used to be to upload a lot of this 360 imagery.
Yeah, can I tell you a little bit about my own experience with the platform?
Yes, please do. You can tell us the good and the bad and the ugly.
So I got really interested in this a while ago now. I was like, oh, how can I get involved with this? I think I looked at using my phone. I was like, that's not really the answer. I want something I can mount on my head when I bike around and contribute. You know? It seemed like a really sort of low friction way to contribute to this awesome project. So I posted on LinkedIn, hey, does anyone have any experience with this? What kind of 360 camera should I buy? Obviously, I read your blog post and I could see that you support all these cameras. And this guy, you might know him, Justin Myers, replied and say, hey, a wee while ago, Meta gave me this camera on the promise that when I was finished with it, I should give it to someone else who was going to continue contributing. So he sent it to me. I put it on my helmet, started biking around my local town here, mapping away. I could see that there was a lot of places that weren't covered. And it was pretty amazing how easy it was, to be perfectly honest. That uploader that you talk about is magical, because it's literally just drag and drop the file into the folder and off it goes. And it was pretty cool. The whole experience was really seamless. And I can say that because I tried also contributing to other projects, and it was painful. Like it was painful in comparison.
Yeah.
So congratulations on that. It's a really easy way to contribute, and I think you've made it really accessible for a lot of people.
Yeah, huge credit to the team on that, because there's a bit of work that they put into. So there's a series of Python scripts called Mapillary tools, which is the underlying logic of how do you take this imagery or video and process it, and how do you understand all these different file formats. And so they did a lot of that work and then incorporated into that desktop uploading software that you used. And it's really important, because that's what makes people want to go out and do it again. If you had to spend your whole weekend writing scripts to process the imagery, you probably wouldn't do it very often. And so, yeah, we really want to make it as easy as possible to contribute. And it's also good that just the cameras enable that too. They're much smaller, they're less expensive. So thank you to Justin for sending it to you and getting us some coverage in beautiful New Zealand.
Yeah, I really appreciate him doing that as well. And I promise to send it on when I'm finished. I also want to say that up until now, I've been talking about imagery, and it's important to understand that it's not just images that we're talking about. We're also talking about video. That surprised me a little bit, because it seemed like, I guess, an extra pain in the ass on your side in terms of the processing. But it makes it a lot easier for people like me, because I don't have to think about the frequency at which I take images. Yeah, I don't have to play around with some sort of distance calculation every 3 seconds, every 2 seconds, or whatever. I can just turn it on, go, and turn it off. I was quite surprised about that.
Yeah, there were definitely challenges with some other cameras in the past, because they had these intervals. So a lot of them had some sort of time-lapse mode, and then take a photo every 5 seconds or every 2 seconds. And 5 seconds is a lot if you're driving at 100 miles or 100 kilometers an hour, 60 miles an hour. There's a large gap, and you might miss things like traffic signs. So that's where video is really helpful, because we can make a determination about what frame rate is useful to extract, and then that just happens in the processing, and you don't have to worry about it. So video has been something that we've started to support a lot more for that reason.
So we talked a little bit about the data that you extract. Are you also building like a 3D model of the world in the background?
Yes, we are. So Jan-Erik spoke a bit about this, I think, when he spoke to you last time, and that's still true. So once you upload the images around New Zealand, like every image, we process it. And the first thing we do is blow faces and license plates, and then delete that original image so that we don't have images that might be privacy compromised. And then what we do is we build a 3D model using a technology called structure from motion, which looks for different points across multiple images, which we, using computer vision, can identify as the same. So maybe the corner of a building, we know it's the same corner of a building across multiple images. And we can rebuild the world in 3D as a point cloud. And then once we have that point cloud, we can start to use semantics and our understanding of an image and try to overlay that onto that point cloud to position objects. So let's say we have an image and using semantics, we think we've identified a trash can or a crosswalk. We can then try and position that feature in that 3D point cloud and give you a estimated latitude and longitude of the object. And that's why a lot of people contribute to Mapillary, is to be able to have that 3D processing take place behind the scenes, but then extract the map data out of it, not just the imagery.
And that must be a huge task given the different sensors that you support.
It's both a benefit and a challenge of Mapillary. Is there are so many different sensors, so many different cameras being used, so many different GPS thresholds. And so even internally, sometimes like there are conversations about what is the quality of Mapillary, and it's hard to give a straight answer. I get asked this at conferences. And in some places we have $50 Android smartphones contributing, and that can be useful because we're still getting photos that show what the world looks like. But then we can have places like Detroit, which have this incredible setup. They're capturing pretty much every day of the year with a very expensive Trimble camera. And so we have the full range of quality, but the team then has to make sense of this and build a point cloud from different sources and different lighting conditions. And I think that's probably one of the most technically challenging aspects of Mapillary.
Do you specify that in the data that you derive from the imagery, from the video, like the sense that it was captured from and the estimated accuracy of that object?
Yeah, the metadata of features generally contains the image it was detected in, and from that you can then discern which camera was used to contribute that image. And so if you're using our API or doing research, and we see there's a lot, people filter by particular users that they know contribute good quality imagery, or by particular camera types that they know contribute high quality imagery.
That makes a lot of sense. And just can you give me a quick overview of the kinds of features you're extracting?
Yeah, it's been pretty consistent over the last few years. We're looking at how we can grow the amount of features. But right now it's things like crosswalks, traffic signs, trash cans, bicycle parking, street lights, utility poles. So those are all the map features we're actually giving you an estimated lat long in space.
Wow. And all of those are being put into OpenStreetMap and available through the API. Is that correct?
There's a few ways. So you can access them through our API. You can access them via our web interface. We have a little toggle where you can turn on map data, zoom into an area, and then download the map data that you've selected and filtered by. And then in OpenStreetMap, in Rapid Editor and some of the other editors, there's a layer that you can toggle that has our vector tiles with different map features. So it really just depends on what problem you're solving. But let's say you wanted to get them into OpenStreetMap. Maybe you're mapping all the crosswalks. You could go into Rapid Editor, toggle the Mapillary feature layer, see where all the crosswalks are, and then just zoom into an area and review the image, make sure that it's actually there, that it hasn't been a false positive, and then you can add that to OpenStreetMap. So they're not automatically going into OpenStreetMap because OpenStreetMap is very much about human curated data, but they're available for OpenStreetMap.
As soon as I asked that question, it's like, of course they're not automatically going into OpenStreetMap. There needs to be a human in the loop, and it makes a lot of sense to run them through Rapid Editor. For the listeners, if you're interested in the Rapid Editor, which you should be because it's incredible, I'll put a link in the show notes to an episode that we've already published around that. Was it 2020 that Mapillary joined Meta?
Yes, June of 2020.
Yeah. And what's how does it fit in with what Meta is doing? How does Maps and Mapillary sort of enhance their organization?
Yeah, so at Meta, we are using maps and location in a variety of different ways. And we're not the only company doing this. A lot of companies now, particularly as smartphone applications became more common, 10, 15 years ago, people needed to answer the question of like, where am I? What's around me? Those kind of things. And that's just proliferated a whole bunch of use cases. And so for us, we have things like Facebook recommendations. What do people recommend around me? Or on Instagram, maybe you're typing in the name of a restaurant and you want to see a map rather than just photos. You want to see the map appear and maybe use that map as an interface to start exploring what's around you. We have wearable devices like Ray-Ban Meta glasses, which are available now, where there's the AI assistant, and people want to ask questions about what's around them. And so we have a variety of surfaces within Meta where people need to know what's around me, where am I, and map data is an essential part of answering that question. So Mapillary is just one source to answer that question. Meta is very much involved in using and contributing to open data sources, though, to answer those questions. And so to that end, we have OpenStreetMap, which Meta has editing software like Rapid that we mentioned earlier. We make donations to the foundation, the OpenStreetMap Foundation, OSMUS. But then we also are part of Overture Maps Foundation, which is like a multi-company collaboration. And so Mapillary is just one of these data sources that's feeding in and making better map data. And we really want to do this in the open because we think that, we know that maps are incredibly hard. The world is changing very rapidly, particularly around things like places, points of interest. I've seen all sorts of stats, but sometimes they're changing it. I've seen stats that they say change 30% on average each year, so that a place, if you have 100 places, 30 of them won't be there anymore by the end of the year. I've seen other stats that put it higher, but the bottom line is they're changing rapidly. And so we need things like street level imagery to be able to get a sense of what's on the ground, has it changed, and make sure our maps are accurate.
Yeah, and this your approach to collecting it by building a community, I think, is really interesting. Not always easy, I would imagine. Like communities, that they must be difficult to sort of foster and nurture.
Yeah, I think every company in maps is trending this way, though, that the traditional approach of just having some authoritative source decide is not the only way. There's still importance for that, but I think most companies that are serious in mapping are trying to take a multi-pronged approach. So there are cases where you want high degrees of confidence in the data, like administrative boundaries. You really want to be careful with when you're taking that data, particularly national borders, but then even county boundaries. Maybe the government's a good source there. But there are other things where that crowdsourced component is really valuable, and places is an example of that. So Google Maps has done a really good job there of building that feedback mechanism to get all their users who are looking at the map daily also then giving feedback back to them about which places are out of date. And so whether it's Google Maps or Apple Maps or Meta and our involvement in OSM and Overture, crowdsourcing is a key part. But yeah, you're right, it's challenging. It can lead to issues around quality. It can lead to issues around vandalism sometimes. That's something that we deal with a lot. But it's definitely like a very minor price to pay for the brilliance that you get from just having the variety of people and the diversity of people. And that's something that I think is missed when you just have one authoritative source. You miss the fact that I see 2 bikes on the wall behind you. You're interested in cycling. So someone like you might have an incentive to improve the map data about cycling in your area. And then someone else is maybe a truck driver. And this happens a lot in some communities where the truck driver cares about where can the truck go down, and then they can update the map and make sure that truck access restrictions are on the map. And so that diversity of knowledge and opinion is really what makes the map as incredible as OpenStreetMap and Overture is today.
Yeah, I think well, if we had more time, it'd be worth diving into Overture a little bit more because I find it fascinating. But I want to sort of hit on this idea you talked about of authoritative data. And it's really interesting to think of authoritative data as maybe something that is crowdsourced, but has been through this extra layer of, ground truthing via maybe the rapid edit, for example. So a human in the loop. And I think, depending on where you are, I think authoritative data is sourced quite differently.
Yeah, absolutely. That's I think a great point. Like to put an authoritative label on something doesn't necessarily mean it's good. It's exactly what you said. It's where is it coming from? What was the method used to collect it? There's terrible authoritative data, and then there's excellent authoritative data. And so knowing a bit more about the origin of that data is really important. And so Rapid has definitely been useful for that. We have things like addresses that cities contribute or building data that cities contribute. And a user can go into Rapid, review it, make sure that it's actually correct. And maybe 99% of it is, but by going through that process, they can remove the 1% that's maybe a false positive or is just out of date because the data was sourced a year ago.
So we've talked a little bit about the uses internally within Meta. We've talked about how, in my opinion, Meta is a really good citizen of the open source geo world, I mean, you make a lot of information data available, you build a lot of tools, you foster a lot of communities through the work that you do and your sponsorship, which I personally really appreciate. Is there anyone else using this stuff? Like, are there any sort of cities, councils, larger organizations that are are doing the thing that we're talking about, that they're investing in, I don't know, using 360 cameras to drive around their local whatever community and monitor things and collect data in this way?
Yeah, I'll give you two contrasting, well, not contrasting, but two different stories, different parts of the world, different methods. One is a company called B Group, and they have, I don't know where they sit in Vietnam, but they're one of the growing ride sharing companies in Vietnam. There are others, but they're a ride sharing company in Vietnam. And you can imagine a ride sharing company really needs to make sure that people get from A to B in an efficient way. They're also delivering packages, so they want packages to get from A to B in an efficient way. They need to know what the endpoint is. So if the user's putting in a place, they need it to be the right place, and they hope to have that business in their database. And Vietnam is one of the fastest growing economies in the world. It's changing even more rapidly than some of the stats I mentioned earlier. And so they have had to get into the mapping business. As a ride-sharing company, they've had to figure out maps. And you've seen this with Uber, you've seen this with Grab. This is just like a natural progression for a lot of companies, is that they realize they have the ability to make the map better. And that's a core part of their use case for their customer. And so they've put 360 cameras on a few of their riders. And if you just look at Mapillary in Ho Chi Minh City in Hanoi, it's incredible. Like, they've captured almost all of the city. And they're doing things like working out where can cars not go down, but scooters can, because a lot of their customers are on scooters. Or maybe a car can't go down this road between these hours, but it can go down that road between these hours. And so that they need to get all the information about this. And street level imagery is a great source. They're also using it for that reason I mentioned before, which is optical character recognition and looking at which businesses are there and trying to position the building entrance more accurately, and a whole bunch of stuff around places and categorization of places. So I really love that one because it's in an exciting part of the world. They're using a GoPro Max camera that anyone can access. And I think they're proving that you can do this in a very scalable way and a relatively inexpensive way, whilst also contributing back, because anyone else who's interested in Vietnam can then go and use that same data.
I think that's the truly interesting thing for me here, is that there's a clear return on investment in terms of business for them. It's solving a business problem, but at the same time, they're making things better for everybody else that wants to use the map as well. And it's interesting to hear you say, like, all these ride sharing apps and businesses and multiple other organizations, they're in the mapping business as well. Because as soon as the devices told us where we were or are in the world, we had to figure out where everything else is in the world. Otherwise, we have no context. And when things are changing, it's difficult to keep up.
Yeah, it's very difficult to keep up. And so I mentioned two use cases. The other one is Detroit, the city of Detroit. And so they're a bit of a different use case in that they have an obligation to their citizens to maintain assets, things like traffic signs and knowing which parts of the city are suffering from blight. And they had this GIS officer called Dexter who came up with the idea, again, of starting with, I think, a GoPro Max or something similar, and just driving around with that and proving that he could collect useful data for the city. And he won a Mayor's Innovation Grant, which I think was acknowledgement that, hey, this is a really good idea. You're collecting useful data. And long story short, he used that to get a much better camera. And then that turned into getting more sponsorship from the city and General Motors, which is obviously the big company in Detroit. And so fast forward to today, they have a Trimble, I can't remember the exact model, but a very good Trimble camera. They have Lidar on top of a vehicle. They have a dedicated vehicle, 2 drivers, and they're driving for most of the year.
Wow.
Collecting data. And their philosophy was in the past, we used to pay companies to do this, and they'll do it maybe once every few years, would have to wait ages for the data. But they realized we have people going around all the time in a city, solving various problems, fixing things. Let's have a dedicated vehicle that's always capturing multiple things, make that data available and open. And they've been able to do things like reduce insurance rates, because insurance is obviously based on whichever statistics they have. And in some places, they thought there were less people living than there actually were. They've been able to like update census records based on the imagery collection and prove that the population was higher than it originally thought. So that's just another example of like really being quite innovative around the city's resources and making them go much further with a dedicated camera.
It's a really interesting idea, actually, because it just occurred to me that, yeah, so they need to collect the base data, if you will, but somebody else is doing the processing. Somebody else is doing the heavy lifting in terms of determining, is this a rubbish bin or is this a street sign kind of thing? And then somebody else is also doing the heavy lifting in terms of distributing that information, making it freely available to people. Because if they had to do all of this internally, my guess is they would have to pay someone to collect the data. The burden of processing it would be on them, and then they'd have to host it and update it somewhere themselves. And this is kind of done for them.
Yeah, and precisely that. Like, and I guess that's why it would often happen much less frequently than it did. It would be more expensive, and they've got a really good write up about their story. But I really like their philosophy as a city, and I think it's something that every city should aspire to. But it's really trying to be smart with taxpayer funds and saying, like in the past, we used to go out and do multiple surveys, right? You do a Lidar survey, you do a street level imagery survey, maybe you do another survey to like manually count all the traffic signs. Why don't we just do that in one drive? We can collect a lot of that information in one drive. And so that's what they're doing now. And yeah, anything a city can do to kind of use taxpayer funds more efficiently and put more money towards the services and service delivery is a really good thing.
Yeah. It's hard to disagree on that one. You mentioned LiDAR. Is there any plans for Mapillary to sort of support the collection of LiDAR? Because we see LiDAR creeping into devices now as well.
Yeah, there's not. It's a question that comes up a lot, and it's a good question. It would be nice, and we could definitely do a lot more if we did support it. I don't think we have it on a roadmap or like the capacity to support LiDAR, but there's so much amazing open LiDAR out there now. And yeah, never say never, but it's something that, yeah, we don't have on our roadmap right now.
So speaking of roadmaps, let's move on to the sort of future gazing section of the podcast. Where are we going from here? We're not doing LiDAR. Big disappointment. A sigh goes through the audience. What are we doing?
One of the really cool things from earlier in the year, one of the blog posts that I think was widely received was one that Peter Konstatter wrote about NeRFs. And NeRFs stand for neural radiance fields, which again might not mean much to the audience, but this is a way to create highly immersive 3D scenes from images as input. So we mentioned the 3D point cloud before. That's just like these isolated points in space, which you can apply textures to them, but they're not great if you're trying to get immersed into that scene and kind of feel like you're really there. Whereas a NeRF is really good for that visual experience. And so it's using computer vision to be able to not just turn images you see into a 3D scene, but it can also create what they call novel synthesis, new views. So imagine you're walking around a statue, you're taking thousands of photos of that statue. There might be bits and pieces of that statue that you missed. It can start to fill that in using AI to kind of guess what's there, but also really like making sure that the lighting looks consistent across the whole scene. And I think that's really exciting because obviously Meta is all about allowing people to experience the metaverse and go into a scene remotely wearing a headset. So I think we'll be doing more exploration around that and being able to teleport to, Australia, where I'm from, and go to the Great Ocean Road or the Sydney Harbour Bridge and explore it with a headset. That's one thing that I think we're really excited about. Also, there's a lot we can do around the data as well, but maybe I'll stop there on NeRFs in case you had any thoughts
No,
there.
I think that's fascinating, and I often think that if this future of virtual reality, augmented reality is going to be realized, the promise is going to be realized, I think we're going to need a lot of amazing base data, to be able to project some of these things onto it, or maybe help people navigate it. We're going to need some sort of realism over it, and I think I see projects like this really contributing to that, at a global scale. So I think it's fascinating.
There's an interesting trend now, like obviously you've had the success of projects like Minecraft or games like Minecraft and Roblox and people creating new worlds. And we have that in Horizon Worlds, which is a meta application on Quest devices. But people also want to go to places they know and love, and whether it's their home or their favorite, landmark in their city. And even at Mapillary, like early on, there were people in France and other places who were really like passionate about preserving the places in their city that they cared about and taking a lot of images. And so NeRFs is a way for them to not just have the images of that place, but then also a model that people can then explore through various mediums and be much more immersed in that scene.
Yeah, and I think when people visit places they know, they want it to be realistic. They don't want, if I know my neighborhood well, I don't want to visit this in a virtual world and have buildings missing and gaps, or I don't want to see a vertical wall sort of leaning at a 45-degree angle. I want it to be accurate, and I can see this is, this is part of what you're building in the background.
Yeah, exactly.
Are we going to see Mapillary supporting Ray-Ban glasses as a collection device?
Yeah, we've tried it. A few of us have tried it. It's definitely like something that we're trying to figure out. So there are a few limitations. Like originally the Ray-Ban Meta glasses had, I think, a 30-second average duration of capture, and then that's been extended. I think it's about 3 minutes now. So that's useful, but like it quickly drains through the battery if you have them on for much longer than that. So they limit the capture time. You also need to rely on your phone's GPS. So we need to like work on the software there to make sure that we're syncing the video frames from the wearable to your phone and utilizing that GPS. And then there's also the issue of when you're wearing glasses, you turn your head, right? Like we can't expect you to just keep a straight head as you walk down the street. And for Mapillary, it's much better for that 3D reconstruction I mentioned when there's a consistent angle relative to the direction of travel. So you're looking straight ahead and continuing straight ahead, or you're looking to the side and keeping your gaze fixed to the side. Very hard to do that with glasses. 360, it's less of an issue because you've got the full perspective around you. But I think it would be good for like limited bursts. Like I would love to see it where if you wanted to use your Ray-Bans to quickly like walk down the street and maybe take a 30-second video of something that interests you, that you could do that and then go back and edit it later in OpenStreetMap, or Mapillary could derive interesting features and put them onto the map.
I can see it for scanning things. Like I want to remember this sculpture, this whatever, and it just being able to walk around and kind of scan it. I think that would be really interesting. I also wonder if this would open up. I realize you talked about positioning being a problem, a challenge. Maybe I should say that. But I wonder if it would open up mapping indoors as well. If you had something that was sort of less conspicuous than a massive 3D camera. A 360 camera.
Yeah, mapping indoors is like a whole other challenge. I loved your podcast. Was it with Hongwei from Mapped In?
Yeah.
He's great, and like hearing the challenges there. I think, indoors you lose GPS and then you have to rely on other localization technologies, but glasses could be one of the inputs there. Definitely like having more imagery indoors, particularly people that are wearing transition lenses and are always wearing their glasses. I do suspect we'll see a lot more of that. I think like a lot of things in maps and location, generally the more inputs, the better, right? Like it's very hard to build accurate maps with just one input. And so you try to take different sources. Maybe the base map could come from a service like Mapped In, where you know the floor plan, and then you have meta glasses to kind of fill it in and know where you are within that floor plan.
So you just mentioned different sources there. We talked about Ray-Ban glasses. The other sort of obvious source to me, I don't know if Ray-Ban glasses is that obvious, but like to me it is, would be drones. And so my question is, could you see Mapillary moving away from this idea of street level to just sort of imagery in general?
I think partially, yeah. We have been really encouraging more sidewalk capture, more like footpaths. I think going beyond where we started, which was all about roads and navigation. Now a lot of our navigation focus is how does a human on two legs or in a wheelchair or outside of a road navigate from A to B. And we've encouraged more of that. In terms of drones, we don't encourage it. We go through various phases where we discourage it more than others. But I think you kind of have to build a different platform for drones because you need to start to filter in altitude and have a sense of how you're dealing with that. That 3D model becomes more challenging because you maybe have a ton of camera views that are taken at ground level or slightly above ground level if you're taking it from a car. And then all of a sudden you have something like 100 meters up. So that can be challenging. The algorithms need to like be retrained to know how to connect those. But we've had quite a bit of success with people uploading drone imagery at a lower level. So you can imagine going down a European street, right? You lived in Copenhagen. If you're going down a downtown area in Copenhagen, there's probably a lot of bicycles parked on the side, maybe cars parked on the side. If you're just walking along or even driving in the road, you might not be able to see things on the side because of those cars and bicycles. But if you have a drone that's flying like higher, you can actually get a pretty good perspective. Probably not legal in a lot of cities, but it is an interesting thing. Maybe that's what they're doing in New Jersey at the moment.
Yeah. What about when we think about the future? Is there an object in the imagery that you'd like to be able to detect that you can't detect today? Or do you have things on the roadmap? We really want to get street lights, or I don't know, we're going to start reading signs ourselves, kind of thing.
I think places is the big one. Where if you look at OpenStreetMap or Google Maps or Overture Maps or like any map database, places is the really hard one to keep up to date. And Mapillary, I think, can play a better role there, discerning what is the name of this place, what type of business is it, where is the entrance located. So that's probably the number one impact that Mapillary could have right now is answering those questions better. And historically, having front-facing imagery in a car made it challenging to do that because maybe only part of the name is visible. Maybe the resolution is not high enough to do some of the things we mentioned before. But now that there's more 360 imagery, I think it's becoming more feasible to be able to do some of the things like building entrance and name detection.
Can you give me a quick run through of what needs to happen in order to be able to identify a place? So we talked about reading signs. What do you need to know? Like when you think about if you had all the imagery you needed, what bits of information do you need to extract from that in order to be able to say, okay, this place, to be able to build up this object?
Yeah, so the first one is reading the name of the place, and that can be hard because there's all these different types of typography and there's different languages, and you need to discern what is the relevant like part of the name here, because it might be such and such name and then Thai restaurant, but you're taking the Thai restaurant part or you're taking the name, you're taking both. Then there's the entrance itself. So some of the larger buildings, and I think this is something that the ride-sharing companies have to challenge a lot with, is a larger building might have a pick-up and drop-off area. It might have a separate area for delivery people. It might have a separate entrance for the customers. Think of a large shopping mall as a good example that might have these three different types of entrances. Discerning what the relevant entrance is a bit of a challenge there. And then positioning the building itself. So like you've got the building entrance, but which polygon is it relating to? Like what does the 2D map look like? Doing conflation. Maybe there's already an existing building there, like, or an existing place. Understanding that. Or maybe there's a different place there. Has it changed name? Or have we just identified an additional place that's opened up to it? So I think those are some of the challenges that come up that make place detection quite challenging.
Yeah, having to talk to the good people at Foursquare as well. So they work a lot on this, and it's not easy. And you mentioned the rate of change before as well, like 30%. That's tough. That's a real tough problem to solve. In my notes here, I can see something about I can see some sort of references to the API, to the developer community, and I wanted to ask, and this might be a really naive question: is there a world where you start to open the API up to normal humans, if you will, via something like by putting an LLM in front of it and letting people ask questions of the data, as opposed to approaching it like the typical structured database where it's an SQL query that you're firing off?
Yeah, I like that question. There's definitely ways we could make it easier. I don't think it's something that we have on our roadmap, but it's something that anyone could build. Like I would encourage you with a lot of Mapillary, the data, the API, to go and take it and build stuff with it. You could build a business around it, and people they build stuff on top of Mapillary, and we highly encourage that because it makes the ecosystem healthier. We have not an LLM, but a Python SDK, for example, that some students built. Fantastic students as part of their major league hacking exercise, and they helped us make the API just a bit easier for people to use, so that if you're familiar with Python and you want to download data and you don't have to worry about map tiles and some of the way the API is structured right now, you can just give it a bounding box, say, give me traffic signs, and download that. But I can see a next step of that being more of a natural language interface like you've mentioned. And it'd be really cool if someone built it, that it probably won't be us anytime soon.
Fair enough. It sounds like you've got your hands full with all the other things that you're building and supporting. I feel like we're coming to the end of the conversation. We've covered a lot of ground. Is there anything you want to leave the listeners with? Is there anything that I haven't asked you about that you'd like to mention before we round things off?
Yeah, Mapillary is what it is because of all the people contributing to it over the last 10 years. So we had actually last year was, I think, the official 10-year anniversary. We had a nice celebration in southern Sweden around that, and really wanted to thank everybody who's contributed over the years and taught us a lot. I feel I'm at a stage now where I'm learning more from other people who are using Mapillary because they find new ways to do things. And so I want to thank everybody. Like the city of Detroit is one example. B Group is another, of like pushing the boundaries of what you can do with street level imagery. And as I mentioned just before, like I encourage people to use the data. It's much more open than a lot of other street level imagery platforms. You can look at the licensing and the terms and see what you can do with it. If you have questions about how to use it for commercial use, our lines are always open. And as I said, we encourage that as well. So we would love feedback. We'd love to know, what would you like to see for us to make it better? And we can't promise everything, but the team is always learning from our users. And that's been a big part of how we've improved over the last 10 years, is taking that feedback and incorporating it back in, making upload easier, as one example.
Is there any particular channel you'd like people to give you feedback on? Like, should they tweet at you? Should they write to you on LinkedIn? Is there a form someone can fill out? Where can they go if they want to give you some feedback?
Yeah, I've never heard of tweeting. I'm not sure what that is, but you can find us on Threads, which is a great. We have a Mapillary handle there on Threads. We have Zendesk, which is you can send us an email, support@mapillary.zendesk.com, which is just where we keep track of all the emails coming in. And then you can probably find us on LinkedIn as well. We're active there. So whatever place you prefer, you're welcome to contact us.
Really appreciate it. Thanks very much, Ed. I really appreciate your time. Appreciate all the work that you've done over the years. And I'm really grateful for Meta. I think, like I said earlier, I think they've been a really great citizen of the open source geospatial world. And they contribute a lot, and they do a lot to support a bunch of different people and a bunch of different organizations and projects. So much appreciated from my side. Thanks very much. I will put links to everything I can in the show notes to help people find and discover more about you. And I hope I see you around.
Yeah, thank you. Maps are much more fun as a collaborative project, and they're much better as a result. So that's why we are building maps in collaboration through Mapillary and Overture and OpenStreetMap. So thanks for letting me talk about it on your show.
No worries. See you around, Ed. Cheers.
See you soon.